hopefully this will go better this time. All right, so now they want us to find the radius. So the formula, we know we've got the arc length. The formula that has the radius, the arc length, and the central angle in it is, again, our arc length formula, S equal R theta. And again, because the first video did not take, just to reemphasize that S is the arc length that's part of the circumference of the circle, part of that outside piece. All right, now they gave us the arc length that's 82 miles, so I can plug it in. They want us to find the radius, so that's our unknown. What I need is the angle, and it's 135 degrees, but I don't want to plug that in as a degree thing. So we're going to have to change 135 to radians, 135 degree to radians. So let's go off to the side and we'll do our little, this will help us practice conversions anyway. So if you remember, you make a proportion and you're going to set two fractions equal. That's what a proportion is. You need one fact that you know to be true. I know that pi is equal to 180 degrees. And so that's going to be one of my fractions. So notice I put radians on the top and degrees on the bottom, and I'm given the degrees. So let me put that 135 right here, and let me solve for what that would be in radians. I'll call it x, okay? I'm not going to call it r so we don't get it mixed up with the radius and that other formula. So if we cross multiply, we get 135 times pi is equal to 180x, but if we remember our little thing about when we first learned proportions, you multiply the two numbers across from each other and you divide by the thing across from the unknown if you don't want to have to write it all down and then solve it every time. So there's my angle in radians, but I need to reduce it all the way. I don't want to work with these humongous numbers. So let's see, we know at least 5 would go into there. Okay? So we put it in the calculator, math enter, reduce the fraction for us. We get 27 over 16 is x without even having to really do all that dividing ourselves. So that's what we're going to put over here.
Did you put the pi sign with it?
Yes, I forgot the pi, yeah. I just forgot to carry the pi. Thank you for noticing that so it didn't end up stuck on the video for perpetuity. Okay, so we stick it in there. Now how are we going to get r by itself when we solve? We're multiplying by fraction. We could divide by the fraction, but that's awfully messy. Do you remember what you did when you wanted to get rid of a fraction and you were solving equations?
Multiply by the reciprocal.
Good. Multiply by the reciprocal. So I'm going to multiply each side by 16 over 27 pi. We multiply both sides by the reciprocal. And when we do that, let's see, I'll go ahead and write this out, 27 pi over 16, and we're multiplying by 16 over 27 pi.
Do we have to change the 82 from miles?
No, it doesn't really matter. We need to know that it's miles when we get done because our radius is going to be in miles since our arc length was given in miles. Our radius will be in miles. So that's how you know what your unit is. Okay. The only thing we really got to worry about changing over is if they were to give us two different units, like in the first problem that we didn't get on the recording because the iPad messed up. If we had radius in centimeters and arc length in inches, we would have had to change them to the same thing. But here we don't have to worry about that. We just know miles is going to be what our radius is going to be given in. Okay. So all this canceled out over here, and let's let our calc, because we've got so much to do. Why don't we just go 16 times 82. And then divide by 27 in our calculator. We'll get that decimal. We can hit math, enter, and if it reduces, it will tell us, and it does, no, it doesn't reduce, because I'm seeing 27 on the bottom. So the answer is 1312 over 27, and that pi is actually on the bottom. That's our radius, and it's in miles. Now, we might want to divide all this out, because if they're asking us, if we're working in miles, that's a fine answer. I don't know if the book gives that or not, but this is probably one of those instances. Does that mean anything to you when somebody tells you how many miles? It's 1312 divided by 27 pi. So we might actually want to give. This is one of those rare instances where you might actually want to kind of come up with a decimal answer for that. And again, I don't know what the back of the book does. Divided by 27, and pi is in your calculator. It's the same thing. It's right below the clear, but you have to hit the second button to get to it. And so that's about approximately 15. We'll just round to decimal place. 15.5 miles is our radius there. There will be a problem like 95 on here on the test, okay? It says the number of revolutions made by a figure skater for each type of axel jump is given. Determine the measure of the angle. So what we want is we want the measure of the angle. Determine the measure of the angle generator as the skater performs each jump. Give the answers in degrees. So we want a degrees answer. And we want a radians answer. So I'm going to make a space for that here just so we don't forget to do both parts, or so that I don't forget, because I'm bad about not remembering. There's an A, B, and C part. Why don't we do the C part, okay? Because it's just, you're going to do the same thing on each part, so let's just pick one part. What about a triple axel? How many of you guys have watched figure skating, you know, for the Olympics, maybe the Winter Olympics are on? You know, you ever hear, well, those of you who have, the skaters, sometimes they go, oh, he did a double axel, he did a, you know, triple axel, the crowd goes wild, okay, you know, it's like a big deal in figure skating, how many times they turn. And, you know, this could very well have been a record turning, and how many degrees or radians did a record go if it turned 3.5 times. Could be another way you could have worded the same problem if you're not familiar with triple axles. Or, you know, it's just how many times did they totally spin in a circle. He spun 3.5 times. What do you think you would do to find out how many degrees is in 3.5 complete turns? Anybody got any ideas? What's one turn? One whole circle, 360 degrees. So if you turn 3 times, wouldn't that be 360 times 3? And then a half turn would be, you would have to add 180 to that. Now you don't have to break it down that small. Couldn't you just say it's 3.5 turns, and I need to multiply by 360 degrees is one turn? And that really could look at it that way. I could sit there and I could count it, 360, 720, and then whatever another 360 would be, and then I could add a 180. And just think about, you know, how many degrees has he gone. But you could just do it all in one step and multiply by 360. That would be the fast way to do it. That would be 1,260 degrees that they would have gone. Now I could do the problem totally different. I mean, I could go back to the very beginning and think, 3.5 turns. Let's do it in radians now. And actually, this might be easier. I'm going to do it that way just because it might be easier. I could convert this now using my proportions. Pi over 180. I could convert it and say pi 1 over 180 is equal to, I don't know the radians, so that's x over 1,260. I could solve that and find my answer. That's one way we could do it. But if you think about this, in radians, if a whole circle is 2 pi, let's see, let's count. One complete time around is 2 pi. He goes around again, that's 4 pi now, that's total, right? Goes around again, 2 more pi would make it 6 pi. And then he goes around a half a time. That's just another pi. How many pi's would that be altogether? 7 pi, right? Honestly, I'd rather do that than do the conversion, even though that's not hard to do in a calculator. So in degrees it was 1,260. In radians it was 7 pi. 97 is good because it gives us both a linear speed and an angular speed problem to work. I'm going to turn the video off and just cut it off and on because I'm running out of space. 2,400 turns per minute. Is that 2,400 turns per minute? Is that giving us something already a little bit, but maybe we need to change some units to it? Look at the units that I wrote on the board on the notes. Do we have anything where we have, like, turns is really talking about some kind of angle, isn't it? Like we can turn that into degrees or radians. That looks an awful lot like angular speed. It's telling me how fast that thing is turning per minute, how many times a minute it's turning. That's angular speed. So this right here is my angular speed, but I got to mess with it a little bit. My angular speed is actually this 2,400 turns per minute, but I don't want turns. I want degrees or I want radians, and they ask me for radians, okay? They say they want it. The A part says, tell me the angular speed in radians per second. So I got a conversion problem here, don't I? I know how many times it's turning per minute, but they want to know per second. So first of all, I got to convert from minutes to seconds. And they don't want to know how the turns. They want it in radians. So this is a big conversion problem right here. It's 2,500 turns, another way of saying turns is revolutions, which is what they used. This is revolutions over minutes. So 24 revolutions in 1 minute, really, is what they're saying. Now, I bet y'all have done, hopefully I've done enough conversions in science that this isn't such a big deal. If I want my answers in seconds, don't I need to get rid of minutes? And I want it in seconds. I want seconds down here. I want radians over seconds. Right here is where they told me how they wanted it. So I need an equal fraction that tells me how many minutes in a second or seconds in a minute. There are 60 seconds in 1 minute, right? So y'all remember doing this in science? And okay, and you did it a long time ago, probably in junior high, if you haven't done it since then. Now, I don't want revolutions. I want radians. 1 revolution is like one circle. How many radians are in 1 circle? 2 pi. So I'm going to just use equal fractions here to get my answer. Okay, so we need to reduce this. We could leave the pi in it. 60 actually divides into 2400, so 60 goes in here once, and I think it goes in there, doesn't it, 40 times? So if you look on the bottom, we've canceled everything out. 40 times 2 pi would be 80 pi over 1, which is just 80 pi radians per second. That's the first part. I'm going to turn the video off so I can try to fit the second part in before the video gets too long to post.